let's get started. So today is session 2, and session 1 we've been talking about installing the software, making the quick start. We also made a stadium with a Mexican wave. If you got, by the way, if you got questions regarding this session, maybe we can grab some time at the beginning before actually starting the session. So feel free to put them into the Q&A. Else, let me show you what we're going to talk about today. So today's session theme is going to be army charging. So we're I didn't write it down, but we're going to first let you know how to fix rendering if rendering is not working on your side and you need to manually install the alternative plugin for your rendering engine. Then we're going to speak about character conversion. So in Tuesday session, we've been playing only, with characters which were already converted. And we ended up with that Golem character file. So we're going to speak about how you create those character files yourself from your own assets. And then we're going to put some soldiers into a scene, make them navigate, make sure that we don't have collisions this time, that they play a nice animation. So I call this navigation and locomotion. So that's going to be the first army we're going to play with. On the other side, we're going to put an army information. So we're going to make a grid, some patches of soldiers, and make sure that they can react to each other using some perception. And at the end, hopefully, we'll have some time also to speak about layout and rendering. So how do you, go back on your simulation results and change them and improve them until you reach the final shot you'd like to have. Next session 3, is going to be on Monday, same hour, and we're going to continue on army, but that's going to be another topic. So probably while I talk, you had a chance to launch Maya and actually load the Golem plugin. Don't forget that if you're opening a new scene, you haven't set up the plugin to auto load, you have to go into Windows, setting preference, plugin manager, and grab the Golem plugin. So here I just open the quick start scene because just before starting the sessions, I want to show you how you can fix rendering. So here I open my scene, and as soon as the scene has been exported and cached, you remember I've got that button here into the shelf, which is called the render checker. And I need to set it up to Arnold. Here we go. And once your rendering engine is set up properly, it's going to analyze the scene, process everything, and let you know what's not correct into the scene. So it just allows you, before throwing a render, which may take a long time, to make sure that everything is correctly aligned and that you won't have any, back surprise regarding it. So I've got a no for the shaders, and every time I've got a no in the checker, I can click on the help button. You will help link. It will bring me to the website and to the Golem website, to the help section, and we'll detail for every single point what you missed. So I've got a help here. Also, my simulation cache license is valid. I don't get a no, but I get a PLE because I'm running the Learning Edition license. And finally, which is the point which interests me today, is this version of Arnold is supported, and it tells me no. And I can once again click on the help, but I'll just show you what does it do. So here on my side, I'm running as it tells you at the beginning of the render checker. My current renderer is Arnold 4.2.0, and I'm running Golem 8.1.3. So when I'm having this configuration with the default installation, it tells me that it requires manual install, and I can check details into the script editor. So let's say you are using, and we're gonna maybe quickly check, if we go on the website, when we go on the release notes, that's the page we went on to on the Tuesday as well. But here I'm running 1.1.8.3, and every time you got a new build or you install a new version of Golem, you can check what's supported. So here, for example, we see that by default we support Arnold M2A 5.0, and we also support Arnold M2A 4.2, but must be manually installed. So Here, in order to have a rendering working properly for M2A 4.2, or it could be for any other versions of the rendering engine that you have here, let's say Redshift 2649 or whatsoever, that's going to be the same process, which is detailed into the script editor. It tells you check details in the script editor. So I'm going to roger that, open the script editor and see what's going on here. So let's close this down. So once again, it tells me the exact same information that right now my install version directory is the Golem directory procedural Arnold 7.0. The rendering versions of the renderers are M2A5. So this is what's been installed right now. And unfortunately, I'm running 4.2, which is installed into Golem directory procedurals Arnold 6.2. So you can see here, by default, we consider that the plugin is installed in that directory, but we should take that one here. So it tells you to edit the Golem module file. So the Golem module file path is listed here, and edit the following variable with this value here. So let me show you what you should do. So you should open that directory. So let's go into that path. We end up with a file called glmcrowd.mod, which is a Maya file, which contains all the information for Golem to be loaded automatically by Maya. I can just open it with a text editor. My text editor is on my second screen. And here, we want to be able to edit Arnold plugin path, M2A extension path, and just path. So we can see we've got Arnold plugin path, M2A extension path, as it's mentioned into the script editor. Right now, it's linking to the directory called 7.0. And here I want to use 6.2 instead of 0.0. So I just have to edit this file and put 6.2 instead to be able to support 4.2. If you were using RenderMan 23, or if you are using V-Ray 4, or if you are using Redshift 2.5, you'll have to edit different files than the one I'm editing on my side. I'm just going to save it here, and I just have to save it, reload Maya, and the next time I'm going to reload Maya, it will reload that file I just been editing, and now my rendering should work properly. So let's throw Maya again. Let's relaunch it. So if the rendering was working on your side, you can just obviously skip that part, and we're going to move into converting our characters afterwards. So let's let a couple of seconds to Maya to start, and I can just reopen my scene quickly. Check my render settings. Yeah, once again, I need to set my rendering engine, which is not set up properly here. There. So I still have the shaders missing because I didn't fix the shaders yet. I still have the Learning Edition license, but now you can see that this version of Arnold is supported. Yes. So I've been fixing now, and every time I'm going to render with M2A 4.2, it's going to work out of the box. So that was just, side note. If you need to fix this, we also have a, complete video tutorial. If you click on the help button, which is next to it, you can just follow that one. And unfortunately, if your rendering engine is not listed here, I'm afraid you'll have to downgrade or upgrade whatsoever. Just make sure that you are, fitting this recommendation list, else that's not going to work. Great. Okay, let's move to today's topic. So first thing we wanted to do today is converting a character. So creating our own Golem character file. So obviously, I'm not going to ask you to, model your own character, create a full skeleton or whatsoever. So what we can do is just take a character from the character pack, and we're going to consider that the character file does not exist for that character. And we're going to create it from scratch and see what's the process to be able to use it for a simulation. So I'm going to go into the character pack, which should have been installed next to the Golem plugin. So on my side, I didn't touch anything. It's going to be into my drive, Golem character pack. I can go into the Golem subdirectory. And if I go in shaders, we end up with Maya scenes, and the Maya scenes are actually T-posed, characters. So it's a Maya file with the actual geometry. So that's the loop dev version of the character. So it's the T-pose character with the skeleton all the props and everything that we can actually use to make our own character. So as we're going to play with, soldiers today, I figured that's probably going to be a good idea to actually open one of those soldiers geometry. So if your rendering engine is not working, is not supported, I just invite you to open soldier Roman _ default. So default means it's not related to any rendering engine, so it's going to display properly. So just a native Maya file. So it's not gonna, it's gonna render properly into the viewport. If your rendering is already working, you can take the one for Arnold, take the one for RenderMan, Redshift, or V-Ray, as you like. So here, as I know that Arnold is working in my session, I'm gonna open Soldier Roman. So we've got two soldiers, the Soldier Fortress and the Soldier Roman. So I'm gonna open that one here, and that's just gonna, import that character into the scene. Once again, the character is within the drive Golem character pack 813. And you can go into the subdirectories Golem and shaders and open Soldier Roman default if you're not sure if your rendering engine is supported. And if you're sure it's supported because you were able to render properly last time, you can just select directly your rendering engine file. Great. So that's a character. And usually when I get a new character, I tend to put an X-ray joint view so I can see how does the skeleton look like for my character. And I can evaluate if it's going to be good or not. So here, that character doesn't have, so it has a skeleton, it has some geometry. We don't have the rig controllers. Doesn't make a big difference if you have them or if you don't have them. But what you really want to make sure is that you have, so that's going to be prerequisites for being able to convert a character within the Golem file format, is you want to have one piece of skeleton, which means if you select a bone, probably the root bone, the hips, it selects every single other joints which is controlling the skinning and the deformation of the character. So it means that any, modular rig, where rigs are broken, where you just have one piece of skeleton in the arms, one piece of skeleton in the legs, one piece of skeleton in the spine. Those are not supported. Those need to be connected all together. So you can see on that character here, the hips is connected to the legs, the spine is connected to the arms are connected to the fingers. So it's all good. Let me just quickly change the size of my bones. So it's going to be into display, animation, joint size. Here we go. Okay, great. So that's better. So that's the first thing I like to usually check. Then the second thing I like to check, if I select that root bone, when I'm going to scale it, it's going to scale the full character. So that root bone is actually controlling everything on the character. So it's controlling the scale. I also tend to apply rotation to make sure that everything is skinned properly, like all the props are following. So that's correct. And also applying a translation just for the sake of it. So, okay, that's all good, which means that we've got a skeleton, which is one piece of hierarchy, which is controlling all the geometry that we have in the scene. So we actually good to go. Great. So don't forget to load the plugin, even if the shelf is appearing on your side. If you click on a button and the plugin is not loaded, you'll get an error. So make sure that if the plugin is not loaded in auto load, that you can go into plugin manager, type GLM, and make sure that that box here is loaded. Else you get the shelf, but you won't get the menu. And if you click on any shelf buttons, it will not work. Great. So if we want to convert a character, that's going to take place into the character maker. So that character maker is the second icon of the shelf. You can see the icon represents a white character with an arrow converting it into some weird kind of skeleton. And if I hover the mouse on top of the icon, it tells character maker allows to convert Maya characters and motions as Golem crowd format. So Golem crowd format GCHA, which stands for Golem character, and GMO, which stands for Golem motion. So let's open the tool. It's open here. And let's see what we have. So we've got a main panel here, which is a grade empty. We've got a drop down at the top, which allows us to change the context between character. This is where we'll be able to convert a Maya character as a Golem character. Also motion to convert a Maya motion as a Golem motion. And motion mapping, which is just the relationship between character and motion, but most of the time we're not going to need those. So that's the first panel we have access to. The second one is apparently we've got tabs on the sides. So if for some reason, by the way, your it doesn't look the same way, maybe that box here is closed or whatsoever, you can just reopen it with a right click into the UI. Then we've got skeleton and geometry. So skeleton, geometry. Skeleton allows us to define how does the skeleton of a character look like, and geometry obviously allows us to define how does the geometry of the character will look like. Great. So what else do we have into the skeleton box? So geometry, it's all grayed out. Apparently, I can't use it for now. And skeleton, apparently, the only thing I can access from that character is a button called Load Selected Skeleton. And I can apparently change some options. So let's see what we have. So let's select load selected skeleton means that first we need to select the skeleton from Maya. So you want to make sure that you select the most top bone into the hierarchy. So here it's going to be the root bone here. So I just select it, press load selected skeleton, and I get a small window which is going to ask me what's the up axis for this character? What's the front axis for this character? So you can actually check within the viewport. So if we look at the scene origin, we end up with a green arrow, which tells us this is what's been detected as the up axis. And we've got that red arrow here, red line, which tells us this has been detected as the front axis. So if you're not happy with that, you can just, change, modify it to fit what you have into your viewport. But here by default, that's the right value. So I'm just going to press OK. You also may have noticed that within the viewport now, within the outliner now, there's a new node called the character maker locator, which apparently is not doing much into the scene. We may notice here a slight difference on the bones. We see some bones, white bones there, not aligned with the current bones in the scene. So that's an actual node which shows you what's going on in terms of Golem onto your character. So by default, they are all at the same positions. So if you want to have a better view of what's going on, you can just move it slightly. So it doesn't have any influence if you move it. That's just for display purpose. So I tend, to offset it slightly so I can see exactly what's going on and if what I'm going to build is going to be exactly what I need. That node here, as always, has some attributes. So if you go into the attribute editor, you can change the bone radius if you want them to be slightly bigger. You can change their side. You can show axis, bone axis, whatever. But here, well, most of the time I just play with the bone radius to make sure that I've got the right data being on. Okay, so what's that locator displaying right now? It's displaying what's going to be stored in Golem as the T-pose for this character. So how is that T-pose being read? It's read from the option specified into the detection mode, which was the only dropdown that we had access when we loaded the selected skeleton. So we can actually change that value if we need it. So first, by default, we're going to consider that the T-pose of the character is going to be stored into something called the joint orient. So if you're a rigger or an animator, you're probably familiar with that term in Maya. So joint orient is what's used most of the time. So it's an attribute from the bones. So if I select any Maya bone, any Maya joint, I end up with a joint orient attribute here, which is a vector, which contains free orientation. And that stores the actual T-pose most of the time. That's kind of where we're going to store the original posture for that character. So we figured, wow, if the rigger made his job properly, probably the right data to read the T-pose from is going to be joint orient. So yeah, let's assume that's good here. Let's say you're not happy for some reason, the joint orient is not set properly. Other thing you can do is read the T-pose, the neutral pose from the bind pose. So the bind pose in Maya, once again, if you're a rigger, you're probably familiar with that. The bind pose is the posture which is used, the bone orientation which is used to make the skinning. So when you skin your geometry, your skeleton has a specific bind pose, a specific posture. So that's the bind pose. So here, if I change to bind pose, doesn't change anything because that character has been skinned in the same posture. So that's a pretty good asset, I'd say. And if any of those data exist or are correct or fulfill what you need, you can just go for current values. So current values just will take what we have into the viewport. So we'll take the current orientation of the bones for that character at that moment. And you can see as soon as I select current values, I've got those folders, those fingers being folded. So what's a good A pose? What's a good neutral pose for Golem? We want to have all the limbs being almost fully extended. So it can be a T pose, A pose. We don't really care, but we want to have limbs almost fully extended. And I'm saying almost just because we also need to know in which direction they fold. So let's say your arm is full straight. We can't really know in which direction they're supposed to fold. Let's say it's slightly relaxed. Now we can know that that's the direction in which your arm is going to fold. So let's relax it slightly on the elbows. Same goes for the fingers, rather than having fully extended fingers, just relax them slightly. But that's usually how studios deal with their characters most of the time. So here, current values will not perform a really good posture for us because the fingers are already folded. So we would like them to be mostly fully extended. So I'm going to go back to my joint orient value, and that's probably going to be something which will be good enough. Great. Okay, so let's move into the next part now that we've defined our T-pose, which is super important, by the way. Make sure that really the T-pose really looks like something which makes sense. And next step will be, let's define how does that character will look like in terms of Golem way. So in terms of Golem way means that we need to know the different I keys which compose your character. So we need to know especially where are the legs, where do they start, where do the legs stop, because we're going to use them to make ground adaptation. So we need to know what's a knee, what's the hips, because if the character walk on some uneven terrain, we need to be able to perform inverse kinematics on the legs to have nice animations. So we need to define I keys on the characters. So how do you do this? You've got your list of joints there. You can see they all have that black dot, and black dot means that for now they're not connecting to anything within Golem, and the whole job here will be to connect those bones to create various I keys. So you get that main space now, which is empty. And you've got those nodes there that we can actually drag and drop to create our own character based on I keys. So no need to replicate that part for now. I just want to show you how those work. So you got 4 different types of nodes. You got a pelvis. So pelvis, as the name tells, defines the root bone of the character, which is the one which is controlling the position, orientation, and scale of your character. So you can only have one in a whole character structure. Then you have spines. So spines, as the name tells, can be used to define a spine chain. So usually made of multiple bones. So you can have as many as you want to. Then you've got something we called limbs. So limbs is just a it's just a regular I key. So this is let me give you examples. So like arms, legs, head, tail, they're usually limbs because you can produce a really huge variation of length using it. Like the arm can really fold a lot, so that's going to be a limb. Once again, you can have as many limbs as you want to onto a character. And finally, you got effectors. So effectors are children of limbs. So anything which is connected to a limb, like fingers, toes, a mouth, eye, whatsoever, which can be connected to a limb, is going to be an effector. So the whole process here will be to drag and drop nodes. Once you drag and drop node, you end up with that little circles, one or multiple circles. We're going to speak about those. And if you click on a circle here, it displays you the list of the bones. And you can just say, okay, my root bone of my character, my pelvis bone of my character is going to be that node in Maya. And as soon as you connect a node, it becomes valid. And within the character maker locator, you can now see that brownish color appears onto your character maker locator, which tells you this is what your root bone is onto your Golem character there. Then you're going to say, probably that's going to be my spine. Once again, no need to do it on your side because we can actually do it almost automatically. So then I'm going to say, okay, I've got a spine. My spine is a child of the root bone. So I'm going to use the same shortcut that I used in the behavior editor, which is the middle click. Oops, sorry. I can middle click this, drag a relationship between those two. And now I'm saying, okay, my spine as a children, which is, my root as a children, which is as a child, which is a spine. And you can see that now, instead of having just one circle, we have two. And those two define the start and the end of your spine. So the spine is composed of multiple joints most of the time. So you want to specify what's the first joint, what's the last joint. So the first joint here of the spine is probably going to be this one here, back A. And the last one is probably going to be that one here, chest M. Once again, if I left click on any of those small circles, it's going to show me who are the children of the root bone. So it's context-based. So I can select back A here. And something I can also do is if I want to grab something from the list, let's expand this. Let's say I know this is going to be my chest being the last node. I can just drag and drop the chest as well and drop it onto my spine node. And now, once again, you can see within the viewport, it now displays as orange. So it means that the spine of your character is made of that part here. If I select the node here into the nodal view, I can also see which nodes correspond to this within Maya. Same goes for the root. So it also provides me context. And if I hover with the mouse, now it tells me the spine. That spine node in Golem is made of the first spine bone back AM and the last spine bone, which is chest M. So while you get a sense that here you have to build your character, it'll probably take some time, to drag and drop the various nodes, like the leg, put one here, rename this properly, fill it with the right parameters, do the fingers. So it's going to take us like maybe a half an hour to do it. But to be honest, most of the time, like, I don't know, 90% of the time, we play with, biped characters, quadruped characters. And all those characters, they always have two arms, two legs, one head, a spine, a root. So we've got a tool, which is called Auto-Compute Skeleton Mapping, which will try to do the job I just showed you, but by itself. So let's empty that space there, and let's press the Auto-Compute Skeleton Mapping, and let's figure what's going on here. So as you can see, it has created you with a structure, some node-based structure, which kind of look like my actual character, right? You can see it has a root bone, it has a spine, and it named everything properly. So it has a right arm, it has a left arm, it has a right leg, left leg, even connected the jaws, the eyes, and so on. And if you check, within the viewport, you can even see your actual display being improved, and you can see your legs being connected, your arms being connected as well, and see how's the characters performing. So when you do biped characters, I would say first press the Auto-Compute Skeleton Mapping. So it will at least produce a draft that you can take advantage from, and you can just fix that draft version of the character if you're not happy with it. So what may be fixed or what should be fixed on that character? So something we haven't really spoke about yet is you may notice that every time you've got an I key, like for the legs, for the arms, for the fingers, we end up with that weird white plane. So those planes define the pull vector of your character. So what's the pull vector? If you're not familiar with that term, that's the direction in which your limb is actually folding. So on the arm, you've got your elbow, and your elbow only have 1 degree of freedom, which is this way here. There's no way I can, revert my elbow or move it on the other side. Same goes for the fingers. The fingers only fold. My key on the fingers. I'm not speaking about, that bone here. I'm really speaking about those ones there. They're only folding into one direction here. So that plane there, those planes there, represent the direction in which the arm is going to be folding. If you want, to understand in which direction it's folding, what you can do is press the check button here. It will run, you will simulate a fold on every single of your chain. So you can, even stop it if you like to and change the value of the fold. And you can see if it's folding into the right direction. Let's assume here that, for some reason, my legs, they are not detected properly. Maybe so here the knees are folding into the right direction. This is the direction in which I expect a knee to fold. But let's assume here, for some reason, your knees are supposed to fold into the other direction. So what we should do is first identify which node that is. So it's a green, and that's on the bottom part of the character. It's connected to those bones there. So it's on the right side as well. So let's go on to the node, the corresponding node. So let's check, and that's the right leg. If I select the right leg, I can see it goes from the hip R bone to the ankle R bone. So, okay, that's probably the right one. It's the green part of the node. So we can see here, we've got 2 green circles being set up. And you can see that next to those green circles, we've got a letter here called Z. So Z is actually the axis in which we detect that bone to fold. Let's say we're happy with that. We can just click on it. And every time we're going to click on it, it's going to toggle the value. So it will go XYZ, minus X, minus Y, minus Z, and automatic. So if I click on Z here, I can go on minus X. So now we're saying that that bone is supposed to fold on the minus X axis. And you can see that on your character, now it's folding into a weird way, but this is what we've been changing. Or minus Y, or minus Z, and minus Z is the opposite of what we had. And now we've got the character which will fold the knees into the opposite direction. So that's really what you want to do here, is you want to check that all the pull vectors, they are set up into the right direction. So let's go back into what we had, which was YZ. Okay, great. Let's see, the arms, they're okay. Usually what we have pain with could be fingers, because most of the time riggers, they give you like fully extended fingers. And, from the viewport there, I can already see that it's not correct. They are like, folding in various ways. So you'll have to, go into every single of those nodes there and just tackle those. So something I haven't really spoke about neither is the fact that in limbs, so arms, legs, head, and in effectors, fingers, toes, we don't have 2 connectors anymore. We actually have 4. So you can see here the pinky finger has pink nodes, pink circles, and blue circles, and the effector has yellow circles and green circles. So what's the idea behind this? the idea behind this, so as my hand is easier to show you, is that when you want to do an aiki with fingers, so you want to grab something with your finger is actually composed of multiple bones. You could actually separate each of your finger into two separate chains. You've got the first bone of your fingers, which are here right under your skin, which we call the metacarpian. So those are the first ones. So when you move your finger, they actually move under your skin, right? If you want to, project this on an arm, your arm is actually also composed of two kind of chain. You got the scapula, which is here, which is actually moving when you try to reach an object with your arm. So that's one part of your aiki. And you got a second part of your aiki, which is actually composed of your actual arm. So from the shoulder to the wrist. And if I go back to my fingers, so I've got a first chain here, which is moving into its own way. And then I got a second chain part, which is the actual finger. So from the third metacarpian to the last one. So when you reach for an object, there's actually two aikis going on. There's one into the scapula and one into the shoulder to wrist part. So that's exactly what it is. We tend to say, okay, when you define the right arm, it can be made of two sub-aiki chain, which contribute to the full aiki. And one is something we call the auxiliary part. So auxiliary part tells you it moves, but not that much. It just moves slightly to contribute to the aiki. And we've got another part, which is called the extension part, which is really contributing to the aiki, making the real extension of it. So this is exactly what it is. So if we take a look at what we have into the auto mapping, it tells that the auxiliary part goes from the scapula to the shoulder. That's expected. And the extension part goes from the shoulder to the wrist. And now I've been defining an aiki, which is composed of those two subsystems. Here, you can also have it sometimes for the hips. Sometimes you've got additional bones next to the hips to define an actual move for the hips. Here, I don't have any additional bones. So this is why if I take a look to my legs, they don't have anything connected for the auxiliary part, but they have something connected to the extension part. So it's not mandatory to fill those auxiliary, so yellow or within the fingers pink, but it is mandatory to fill the green part and the blue part. If you don't fill them, the node is invalid and would not be saved onto your character. So yeah, it made a pretty good job about it. So we can just stick with it and we'll be good. This panel here is also the place where you're going to specify if you have blend shapes. So my characters don't have blend shapes, but if you had any blend shapes on it, that will be listed here. This is also where you're going to define rolled bones parameters if you want to scatter some orientation on your arms or on your legs on rolled bones. I'm not going to address that part, but we've got tutorials regarding this. And last thing, which is super important, which has been introduced in 8.1.3. So if you're running the last version of Golem, we've been introducing something called perception shape. So perception shape, and we can display that perception shape. It shows you how does the character looks like in terms of avoidance. So that's what's going to be represented for the characters for navigation and avoidance. Obviously, when we do avoidance on the characters, before we're just approximating characters as cylinders. And the cylinders can be pretty convenient when you do biped and so on. Obviously, we couldn't use, the full geometry. It will be way too complex, way too heavy to approximate and detect collisions between characters based on the full geometry. So approximate them with cylinders. And now we've been changing this. We can actually define a box. So you can auto compute the perception shape. So it's going to try to, figure what is the best shape for this. And if you're not happy with that, you can just change the value. So if you want your characters to be slightly bigger, you can just fix those values until you have something which corresponds to your actual characters. So cylinders were not convenient, especially when we were doing horses, when we were doing cars. they could not be really approximated with cylinders. So now with that new system, you can define a box which really fits with the character, and that just helps into having better avoidance. So here I've been shifting my locator slightly, so this is why the two are not aligned. So if I just go back into 0, 0, 0, so now I can align the two of them, and I can see if that's correct. I should make it probably a bit bigger. Great. Okay, so here, that character, the state it is right now, it's already a valid Golem character. Just from having converting the skeleton is good enough to start making an actual simulation. I don't need to have the geometry, because the geometry is only required for rendering time. So obviously it helps having the geometry when you are CrowdTD, because you can see the full appearance of your character. But let's say for some reasons the modeling is not ready, the skinning is not ready, you only have the skeleton. But that does not prevent you to start your scene. You can actually start your scene right away. Just to make sure that that's true, what we can do is we can save right away our Golem character. So we're going to save it. So you can use the floppy icon. So use the save button, and we're going to save it into a home directory. So I'm going to create a Golem directory into my project, and I'm going to save that as Roman Soldier 01. And also, that's just a good habit I'm having. But as soon as I work on converting my own character or a customer character, I always like to have at the same time in my character conversion scene a simulation, so I can check step by step if everything is correct. So here what we can do is we can check if our character that we've been doing is correct. So I can just create a new simulation that I've been doing on last Tuesday. So what I'll do is, as always, I'm gonna create a new entity type node. The entity type node will allow me to load a Golem character in my scene and populate it. So I can create a new entity type. Obviously, the character file I want to load is the one I'm working on. So that's my Roman Soldier 01 GCHA. So GCHA for Golem character. Awesome. So I can set up the scale and so on. And by the way, if I want to have the exact same scale than my character, I can just put my ratio mean and max to 1 and 1. So it won't have any scale variation. And as always, I can rename this Roman Soldier, let's say Roman Soldier type. Great. And if I want to actually see how does my character looks like, I need to populate that guy. So I'm going to use the population tool. If I double click on it, that opens the toolbox. Here, I just want to have one character next to my main character. I just want to compare those two together. So I'm just going to use a grid, put it next to my source character. It creates, as always, a 5-slot grid. So that grid is supposed to be 6 by 10. So here I don't want to have 6 by 10. I can just say I want to have a grid of 1 by 1. I can change my orientation to make it aligned with my actual character. So that's going to be 270 degrees. Great. So my character will be populated in that spot there. And final step, as always, if I want to actually create my character, I need to press the create button. And now if I rewind the simulation to frame 1 and play a frame, I can see how my character looks like. So as we don't have any geometry on that character so far, we only get a view of the actual skeleton. But that's how the T-pose has been detected. So I can see my T-pose, I can see my fingers, I can see my spine, my legs. So far so good, looks pretty nice. And usually a good practice will be to apply an actual motion on that character to make sure that when it moves, everything moves properly, like the legs are folding into the right direction, like the arms are folding into the right direction, and so on and so forth. So I can just add a new behavior on that character. So just to recap, slightly what I'm doing here at the moment is I want to check if what I convert for Golem is valid. So I've been creating like a mini simulation of just one character. So I started by creating an entity type. So I created my entity type with my entity type button here, and I loaded my Roman soldier 01 character file. It allowed me now to populate my scene with that character. So I created a population grid tool that I set to, let's go there. I set to a grid to a 1-1. So that's just a 1-1 crowd, which I set up into the right orientation. I press the create button. So it allows me to create my actual crowd. And then I rewind my simulation, press a couple of frames, and now I can see my T-pose character appearing. So let's check the animation now. So if I want to apply an animation to that character, to that Golem character, I actually have to assign a behavior. So I'm going to open the behavior editor, and I'm going to assign, like we've been doing a couple of times on Tuesday, I'll be assigning a motion behavior to that character. So I've got my Roman soldier type here. I can double click to open it. I can see my behavior graph, and I'm going to assign a motion behavior. So that's going to be the third icon into the library. So now I'll play a motion clip on that character, and I can grab any motion clip from what we have into the character pack, because as I've been saying multiple times in the previous session as well, we can do retargeting in Golem, so we can apply any motion on any character anytime. So if I go into, let's say, locomotion, and I just take a walk normal animation, but you can take whatever you like to here. I'll take a walk normal animation, double click, so it's assigned it to my character. And if I press play, now I can see my character moving, and I can see that, you know, the legs, the arms, everything is moving properly. So that gives me like a good feedback about the fact that my skeleton now has been correctly prepared. And now it's just a matter of assigning some geometry on top of my character. So that's the exact second step we're going to do: create and convert our geometry to make it available for the viewport and for the rendering. Before I move to geometry, any questions so far regarding skeletons, various features that you may have on your side, on your characters, and you're afraid that they will not be supported or whatsoever? And I just take this to drink a little. Okay, so no questions apparently, so that's good. Excellent. So let's move to next step here, which is assigning geometry to the character. As I was saying, making a simulation with skeletons, fully valid. I can even export a cache and you know, bake out my sim. That would work. But obviously, if I want to go to render, or if I want to see my full geometry with all my props, it's always better to also convert the geometry at the same time. So let's move in my character editor again, and let's jump into the geometry tab. So just a quick note: if you're not able to open the geometry tab when you click on it, if it doesn't react, so that's something we noticed a couple of times, but we couldn't really identify the issue. So it's probably related to the library that we are using. So if for some reason it doesn't refresh, or you're not being able to access it, what you can just do is go into the drop down here, move from character to motion, and move back to character, or whatsoever, just to change the status of that drop down and go back to character. And that should allow you to now click on geometry. So not really sure when that happens, but we see that happening here and there. So just a quick tip there. Okay, when we go into the geometry tab, now it's not grayed out anymore, and we're able to work on our geometry. And as you see, we've got a nodal editor again. And rather than having bone nodes, we have geometry nodes. So what kind of geometry nodes we have? We've got an assets group to group assets together. We've got meshes, mesh assets. We've got fur, shading group, shaders, shader attributes, skeleton overrides, blind data overrides, physics override. So we're not going to talk about the last three, but we're going to play with mostly all of the others. Well, not the fur because my characters don't have any fur, but mostly the others. So once again, I can drag and drop nodes, connect them together, name them properly, but it's going to take me a long time here. So rather than creating everything by hand, what's probably more interesting here is to directly be able to select your geometry from Maya. So let's take a look how the geometry is organized. I've got the body and the eyes. I've got accessories, weapons grouped all together, outfits. Okay, great. Not so bad. So you can organize the data the way you'd like to. No big issues with that. But keep in mind that we are going to replicate that same hierarchy within Golem as well. So what we may want to do is first select a group which contains all the geometry. We want to go into the character maker, and we want to select the character node to say that what we have been selecting here will be attached to that node here. We'll just have one, but if you select, a geometry afterwards, you can select on which part it will be attached. And if you press on that button there, so the button which represents the import geometry menu, so you can see it's a mesh with a blue arrow going from left to right, which allows us to import the geometry. So if you press on that button there, you can see that it's creating a huge graph of data. So what's that huge graph all about? So let's maybe zoom in. We've got a group called MDL, which is exactly the group we've been selecting. That MDL group is connected to Roman accessories. So Roman accessories is that group there, and that guy is also connected to more subgroups. So it's exactly replicating your hierarchy there. You can see that MDL is also connected to directly meshes, my right eye, left eye, body. Every single mesh gets connected to a shading engine. So once again, that's the same stuff that within Maya. In Maya, you assign surface shaders. The surface shaders are they're attached to shading engine. So replicate that same mechanism there. And the shading engine, they are connected to a surface shader. So once again, we're reading everything that we have. Apparently the body there is going to be shaded by a surface shader called SH Roman body whatsoever. How do you navigate into this, by the way, because you've got that huge graph, and obviously if you press on a minus sign on any of the group, you can close it down. But let's say you don't want to press any of those minus sign. What you can do is you can do anywhere into the hierarchy. And if you press, if you just press Shift key and use your mouse wheel, if you use your mouse wheel up, it will close one level of hierarchy. Every time you move your mouse, your wheel mouse up, it closes one level of hierarchy on the node that you are pointing. If you press Shift and wheel down, it will expand one more level of hierarchy. So that's just a good way to quickly close some piece of the tree when the tree is really has a really high depth, and navigates in the various area and see what's going on. So once again, if you want to close, you can just press Shift, Alt with your mouse, any node, and just wheel up, and wheel up will allow you to, anytime you wheel up, it will close one level of hierarchy until it's fully closed, and wheel down will allow you to open a level of hierarchy. Okay, next step here, you may notice that on the MDL group there, we're having some 50 numbers wrote on every single arrow. So what's going on here? So those are what we call weights. And for now, Golem is saying that your character, the MDL group, is actually a variation. So that means that my character are going to be either this mesh, or this mesh, or this mesh, or what's in that group. And that group is as well a variation, and weapons are going to be variations as well, and so on and so forth. So obviously that's not what I need here. I don't want my characters to be either one eye on the left side, another eye on the right side, or a body or a weapon. So that's not going to be a variation there. So if I want to disable the fact, so why did it thought that that's a variation is as soon as you got multiple meshes in a group, we figured probably that's a variation you want to do there. So if you don't want to have a variation, you just need to click on that slider icon. So right now you can see it's white out. If you click on it, it's going to go blue, empty, and you can see the weight disappeared. So if you don't have the weight anymore, it means that it's not a variation, but it's a composition. Your characters are made of a left eye, right eye, a body, and accessories. So here we've got a full list of hierarchies, and everything has been weight up. So obviously we don't want to turn all those icons down. So what we can do is also on the main node, on the MDL node, we can right click and we can use recursively disable weighting. So that means that it will go in the full tree and it will disable weighting everywhere. So let's disable weighting everywhere, and we're just going to tune in weighting variation when we need it. So, okay, let's close down my hierarchy slightly and let's see where's the variations gonna go on. So, okay, here MDL is not a variation. My characters are made of accessories, body, left eye, right eye. In the weapons, let's expand this. So here, my weapons can be either a staff, either a broadsword, either a shield, either a spear, oval shield, spike, whatsoever. So here, clearly that weapons group there, that's a variation. I don't want my characters to wear all of those assets at the same time, especially because those assets, they are all, put into the same hand. And actually, I think sword, well, actually, yeah, we put shields and okay, they're all into the same groups. Okay, that's not the best sorting there, so we'll have to probably reorganize the stuff afterwards. But yeah, clearly we need to say that's a variation here. So let's enable variation on the weapons, and you can see that now we've got our weighting system back. Great. And outfit, what do I have into outfit? I've got my armor, so fabric, chain, leather. So okay, all good. So that's not going to be a variation. So, okay, we probably have to reorganize this after, but I just want to test if it's working, at least like this. So we've been defining a character now, the geometry. So my characters are made of eyes, body. They are made of outfits as well, and they are made of one weapon, which will be assigned to your characters. You can obviously sub-cascade variations internally. So you can, make a variation of weapons, and into weapons, you can say, okay, I'm going to have a variation of swords, and into swords, I'm going to have a variation of the blades, and into the blades, you can have more variations. So you can have as many cascade of variations if you want, that you want into your characters. So no limitation regarding this. Great. So we're almost all good. To be all good with this, we need to export a version of the geometry into a geometry file. So obviously, when you do a Golem character, you may want to have different versions of geometry, especially when you do crowds. You may want to do a high definition of your geometry, and maybe a mid definition, maybe a low definition. So it means that you have multiple representation of your geometry, And those multiple representations of your geometry need to be exported into a Golem file. So that contains all the, the faces, the vertices, the UVs, and everything which is geometry related. So if we want to export the geometry, we need to go back into our first node, the character node. We can see right now the GO icon on it is empty, which means we didn't have exported any geometry yet. So we need to jump into that node there. And when we select that node, we end up with a asset properties on the right side. Once again, if you don't have it, you can just right click to open it, right click on the menu bar, and it shows you if you want to open the asset properties, yes or no. And if we check the different icons that we have, especially the first one, it shows that we can export the geometry file. So this is exactly what we want to do. We want to bake that character geometry in the geometry file. So I'm going to press that button here. It's going to ask me, where do I want to export this? So I'm just going to export it next to my Roman soldier. So I'm going to name it Roman soldier GO, make a version. So 01. It's going to be saved as a GCG file, which stands for Golem character geometry. And save. Well, I get some errors. Let me check. Tangents, tangent. Well, I can just ignore those. Okay. And as soon as the geometry file has been saved, now you can see that the geo icon is filled up. If you select the geo node, you can see that now you got information about your character. So where it's been saved, what's the bounding box of the character. And if you want to use LOD, you can set up your LOD minimum distance and maximum distance. And as soon also as you've been saving your character geometry, you can see that here you end up with a way to control your weighting. So we've been defining that we've got a variation on a character. So weapons, and the weapons can be either the sword or whatsoever. And into that panel here, we can define what's the weighting. So we can say, I don't know, my character here, none of them will have a shield. So let's put the shields down to 0. And none of them will have a staff. Let's say broadsword, spear, spike, gladius. Let's put, well, do whatever you want to. Put your weighting the way you want to. And that weighting is what will be used to make variation of your character at simulation time. So those are going to be overall rules. So you don't have to make sure that this makes 100. We're going to, compute the percentage for you, and the percentage are going to be displayed here. So at the end of the day here, I'm going to say 20% of my crowd will have the broadsword, 50%, almost 50% of my crowd will have the spear, and 31% of my crowd will have the spike. And that's just a general rule which will be assigned to your characters. And obviously at any time you'll be able to grab a bunch of characters and override the geometry assignment that they had. If you're not happy with an assignment, you can override on a group of character on just one character and have it working properly. So final step, and we'll be done with that character, is that we need to save this now because we've been changing the geometry, we've been changing the skeleton. So anytime you apply some modification, don't forget to save it, that character file, because the simulation part reads what's on the disk. It doesn't read what's in here. So let's save it onto our characters. Well, let's maybe save another versions, to be honest. Roman soldier 02. As I've been changing the file name, it means that I need to go back into my entity type, load my second file. If I throw the sim, I get my character moving, and you may say, well, I still have my animation, but what's the geometry? So if you want to change the way the character is displayed, you can actually check the display attribute. So next to the green color swatch, there's a drop down called display mode. So if your geometry was set up properly on the character, we would have set it up by default on Geo. But here, as we didn't have the geometry when we first loaded that character, we'll fall back into animation bones. So I can just switch the display mode. So I have multiple ways, by the way. I can show cylinders, which is just the dumbest way of display characters. I can show physics shape, which is what will be used for physics simulation. I'll talk about that later. And we have GPU render previews, and GPU render previews allows you to show how the character looks like in terms of geometry. And now we can see our geometry with the way we've been defining variation. So we've got a spear on the character, which is exactly what we've been defining. And now we can see our character. That spear repetition, by the way, anytime you go back into your assets repetition. So here apparently is wearing probably the spike or the spear. No, probably the spear. Yeah. Well, let's say I just want all of them to wear a sword, for example. I can just put all my weights to 0, save the file, rewind the simulation, throw it again, and now my character there having a sword in the end. So all your weighting system that you're defining into your character file, that's something you can view and reevaluate anytime onto your character when you open and create a simulation. Great. So I know that's a big part, and I really went super slow on this, but there are way more options, obviously, that you can touch. But I really wanted for you to feel what it takes to convert a character. So usually that's the bottleneck when you start a production. You always need to convert a character. So this is probably one of the less funniest part of the workflow, to define the keys, to define the geometry, to define the rules. But yeah, that needs to be done. But once it's done for real. And now you can, jump into making your shots and playing with your actual characters. But yeah, that's what it takes. So you need to first convert your skeleton, also convert your geometry, and save it. That makes a golem character, and that golem character can now be used into a simulation, and you can apply any animation on that guy. So all that makes sense. Let me know if you were able to convert your character. So skeleton, geometry, or if you didn't try at all. Obviously, the thing, so I can see your question. So by the way, put your questions into the Q&A, especially because I don't always have the time to review the chat box. So please put your questions into the Q&A and not into the chat box. So if you got, fingers are broken, that's the questions I get. Should I reload the animation to fix it? Well, probably not. They're probably broken because we didn't fix them, on my actual regular characters. You can see that all the pulse vectors, they all like reverted all, in every single direction. So whatever, depending on the animation that you are playing onto your character, that may not falling into the right direction. So this is probably why you're not seeing something properly. So whenever you're having an issue with the way the character deforms, it's probably because of the character file and the way you've been mapping it rather than the animation itself. Especially if you use a golem animation, you can assume that the golem animation is correct and is fine because we've been converting it ourselves and we're pretty sure that they're all good. So if you got an issue with your character, that's probably because the character is not correct, and you have to figure, did I map my fingers correctly? So here's the pole vector, all the pole vectors in the right direction. If no, put them into the right direction, save your file, reload the sim, and see what you get. Another questions I get, can you rig a spider boat crowd, horse and riders, zombie tentacles, spider boats? Yeah, totally. That's the full point of having a nodal editor, right? Having a nodal editor means that you're not limited to any morphology that you may have with Human IQ or whatsoever. You can, connect as many limbs as you want to or whatsoever. If you want to, make your mind how to do this within the Golem character pack, if you pay attention to the different various characters that we provide, there are actually, there's a arachnid character. So you can open and expand that one and see how it looks. There's also a, where it is, cavalry soldier. So that's a rider on top of a horse. So, you can just open those. They open a new tab. So that's my spider. It has 4 legs on the ground. It has a tail. It has 2 arms. I'll let you check how does the geometry of that character looks like. It's pretty funny character. But that just to give you idea of what's the range of stuff that we can do. And if I open the cavalry soldier, that's my setup here. So obviously it's way more complicated as soon as I've got more keychains to solve. So you've got your rider, which is supposed to be not really sure. So oops, let me fix my mouse for a second. So you got your horse, front part, legs, back legs, and all the other rest there are the riders, left arm, right arm. So they're just, 2 hierarchies being connected together. And if you look into, the viewports, and I'm going to remove the display of the perception. Yay. That's how the character looks like. And, that can be inspiration. If you need to create your own characters, you can take a look at how we define the characters ourselves. And obviously, as studios can come with really crazy rigs, a lot of different types of characters. We got plenty of tutorials to help you, tackle the different parts like a squash and stretch, blend shapes, roll bones, or whatsoever. So, well, a fair amount of you guys were able to, well, most of you guys, which try to follow the sessions, were able to convert the characters. So well done, because that's really a part which can be really tricky and difficult. So well done being able to figure this. Another questions I have is, what version is this? That's the latest one, which is being released on Monday. It's a Golaem 8.1.3. We really recommend you to go on the latest version because there's so many great features into that latest version. And we also fixed a lot of things into the UI or make it more accessible for the newest version. Great. So, okay, we've been converting our characters successfully, so that's great. Let's move into the next chapter, which is trying to make some armies interacting with each other. Before doing so, let's do a break. So it's 7:15 on my side. Let's break for just 5 minutes and meet at 20. So yeah, see you in a minute, and put your questions in the chat box if you got any coming. Okay. We're still live, yeah. All good. So let's resume our session. Any questions maybe in the meantime? So apparently no. Great. So let's move into the next topic, which is making some army charging each other. I'm going to start a new scene here. And I'm going to start creating a new simulation. So for maybe the purpose of that scene here, it could be maybe interesting to create pretty quickly, just a small environment in which we'll have the characters interacting with each other. So maybe what we can do is just take a couple of minutes to create your own geometry. Please, by the way, remind that if you got any questions, put them into the Q&A section so we can monitor them and write an answer so it don't get lost into the chat box. So keep in mind also that the unit we're going to use is going to be the same than usual. So we're going to consider that a 111 unit cube is 1 meter because the characters are made as meters. Once again, that can be changed, whatever the value you want to use. But here in our scenario, we're going to use a 111 1 meter unit. So let's keep that cube in the scene and create a battlefield, which will be big enough to maybe hold, I don't know, 500, 600 characters. So I'm not really a good modeler. So probably just do a plane, sculpt it slightly and put 1 or 2 obstacles into this. Let's provide maybe more vertices. Sculpt this. Provide some bumps. Let's try to keep it realistic for a battlefield. No stairs, huge slopes or whatsoever. And also no need to make like a really huge environment, which is like kilometers squared sized. Just something where I can have my characters evolving. What's the weight, the strength of my brush? Okay, good. Okay, let's do a valley kind of environment, something like this. Okay. Let's smooth it slightly. Okay. And let's also put maybe a couple of obstacles in the way. So I don't know, maybe there's a hole somewhere you don't want the characters to go. So let's put a sphere. And maybe there are a couple of trees you also want your characters to avoid. So let's say that's going to be my, oh, it's pretty huge for a tree, right? So yeah, let's put some trees here and there. Maybe duplicate that. I can just, use some proxy geometry here. No big deal if it's not the real actual geometry. Great. And let's group that geo, name that environment. So I keep my outliner clean, and let's save that scene as well. There. So that's session 2. And that's going to be my charging armies. Great. So yeah, I'll give you a couple of minutes to end up your environment. Once again, keep in mind that 111 cube 111 is going to be 1 meters. So my environment is maybe, yeah, it's big, but whatever. Great. Okay. So yeah, let's get started with that scene. So my scenario with that charging army scene is that we've got 2 sorts of characters available into the character pack, 2 types of soldiers. We've got the Roman soldier we've been playing with as the one we have converted like right before. And we also have another soldier called Fortress soldier, which is a kind of medieval soldier. So let's say we would like those 2 types of soldiers to charge. Well, one charge the other. So we'll have the Romans in really nice formations, like you would expect them to be, like really slightly sorted, precisely sorted. And we want to have those other kind of soldiers, the medieval soldiers, to just rush and be pretty disorganized and just to run towards the Romans, right? So for this to work, we're gonna need to import 2 entity types. So one is gonna be my Roman soldier, and the other one is gonna be my fortress soldier. So let's create the corresponding entity types. And by creating 2 entity types also means that they'll have different geometry, obviously, but also different behaviors. I'll have my Roman making some specific animations. I'll have my soldiers, my fortress soldiers doing some other specific behaviors, animations. So let's create those types in the scene. So if you go into the character pack, 813 Golem characters, there's the soldier Roman. So let's bring that guy first. It's going to ask me to load the shaders. So if your rendering engine is working properly, you can load the shaders, for your Roman soldier in your rendering engine. If they do not work if your rendering engine is not working properly, you can just use the default version of it, which doesn't have any specific shaders for this. So here my rendering engine is working. So I'm going to load my soldier Roman _AR, which stands for Arnold. So it's going to load it into my scene at the scene origin. Okay, great. And let's rename that node. So I'm going to rename it Roman type. Great. And let's create another type, which will hold the soldier fortress. So please mind that there are soldier fortress, but there's also soldier fortress arrow, which is just an arrow character. So that's just a stick with some feathers on it. And there's also a soldier fortress ball, which is used for catapult. So those are just simpler character which can be used with this Fortress Soldier. So make sure that you are not loading those, that you are actually loading the Soldier Fortress. So I'm gonna do Soldier Fortress there, open it, and load the corresponding shader. So Soldier Fortress AR shaders. Great, and let's rename this. I can rename the Fortress type. So, okay, I've got my two types now. Green guys, blue guys. So green are going to be Roman, blue are going to be Fortress. So usually when we've been creating the entity types, the next step was about to populate the scene. But before populating the scene, we've been creating an environment here that we would like our characters to be able to take into account, especially the fact that we've been creating obstacles. So we want our characters to be able to avoid those obstacles, or at least know about them and react to them. So before, yesterday not yesterday, on Tuesday, when we were creating the stadium, we're creating a terrain node. That was pretty handy to make ground adaptation, but here we also need to compute obstacles in the scene. So we need to perform an extra step for the terrain node to be created. So first I'm going to select my geometry, which compose my environment. So all of it. And I'm going to open a tool we haven't been playing with so far, which is the navigation mesh creator. So that's the fourth icon into the shelf. The icon represents a Maya geometry being converted into some sort of representation. And if I hover the mouse on top of it, it tells it's the nav mesh creator, which allows to convert a selection of Maya polygons as a Golem navigation mesh with extension GSE, so for spatial environment. So select your geo, open the tool. And when you open the tool, you end up with that small window, which shows you how many triangles you've been selecting, what's the size of your environment, a couple of feedback about your geo. And you can see that you can control some subsets of parameters, like what is the maximum step 8. So those parameters are going to be used to detect what are supposed to be obstacles or what are supposed to be just environment. Let's assume that our characters maybe are, or let's remove the cube, by the way, from my environment here. So let's assume that my characters are going to be that big. Maybe for them, that's not an obstacle. That's just some geometry they can step on. If my character is that big, that's totally an obstacle, and I want them to avoid it or actually move around it. So select the geo. So maximum step 8. So here we're telling that 0.41 meters, which means 41 centimeters, is the maximum 8 my characters can climb with their actual legs. So 41 centimeters is usually the size for the average size for humans, which they will probably go around it. Then you've got minimum radius. So minimum radius is 15 centimeters. So the diameter will be twice the radius. So it's 0.3. So 30 centimeters is the minimum 8 under which I cannot go. So it's not a corridor. It's something I can't go through. So those are set up for, human-sized character usually, but you can just change them depending on the type of characters that you have. Minimum clearance is the size under which I will consider my characters can go, or if it's under a certain 8, that will not be able to go through. And finally, I've got a degree angle. So that's the maximum navigable slope. So that's the actual degrees for the slope I can climb, and 45 degrees is probably the highest 8 I can go through. So here I've been selecting my environment group, but you can also select the geometry separately if you want to. And I've got a questions like, how did you group the environment in that folder? So that's a Maya tip here. But if you select a bunch of nodes and you press Ctrl-G, that creates a group in Maya. So that just created that group, and I just renamed it. But yeah, you can select also the geometry like separately, will not make any difference, or just a group. So with the geometry being selecting, selected with the default attributes here. We're going to press the compute and save button, and we're going to save that into a project. So that's going to be a new asset. So it's going to Golem, create a new environment assets. And I'm going to save this as my charging terrain 0, 1. So I'm going to press save. And it will take more or less time depending on the size and the complexity of your geometry and the size of the environment. But at the end, I can close the navigation mesh tool. At the end, you will create a GLM environments group. And if we expand it, we figure there's a terrain node. And that terrain node now is displayed in a specific manner. So we've been using the terrain node when we were playing with the stadium, but we didn't get that red borders. So you get those red borders as soon as you compute those obstacles like we just did. So we've got our charging terrain 0, 1 here being saved. And we're saying that the geometry on which we're going to adapt the feet on is defined into the transform group called environment. So just a quick word about the terrain. You can have as many terrain as you want to in your scene. We don't prevent that to happen, but you can only have one terrain being active for one simulation. So let me maybe have a quick word regarding this. So let's say your terrain has changed. Maybe there's more obstacles in the scene. So let's say that guy here, there's another one here. So obviously, if you want to take this into account, you have to recompute the navigation mesh. So that means that you have to reselect the geo, open the navigation mesh tool, process your right parameters there, and compute and save, and maybe create another version of your spatial environment. So let's make another version of it. And now, obviously, when you look at the viewport, looks nice. You got that new border around your obstacle. And so far, so good, right? Not really, because in your scene now you have 2 terrain nodes. And obviously, you are seeing the 2 terrain at the same time. So you've got one which has every of the same obstacles, but without that one here, without the new one we've been heading. And you've got the second one which has all the obstacles. So how do you know which terrain is going to be used by your characters? So at any time, if you got multiple terrains and you want to make sure what's going on and what terrain your characters are using, you need to go into the manager. Well, by default, the first node is what's going to be active, but you can go into the manager here. So the manager, once again, is the node which contains all the global data which are shared by all the characters. And you got a panel called environment attributes, which is closed by default, but you can expand and you can see you've got your terrain locator, and the terrain locator, which is used by default for the character, is going to be terrain shape 1. So let's say you've got multiple terrain and you want to change your terrain for the whole simulation. You need to, say, okay, the terrain I want to use is shape 2, which is the one which contains all the obstacles. If for some reason here, let's say we go back to 1, if for some reason you delete the terrain which is connected to the manager. So here I've been deleting the terrain which was connected to my manager. And you go back into your manager, you can see that now no terrain is assigned to your characters. So your characters don't know anything about the obstacles anymore. So if you delete terrains, make sure that you relink this by yourself so your characters know about it. That was just a side note. Also, questions I get pretty often when I show that part is, can those objects here move? What if I keyframe them? If you keyframe them, they are not static obstacles anymore. And if they're not static obstacles anymore, you don't want to process them with the nav mesh creator. You only want to process in that tool stuff which will not move for the whole duration of your shot. So that can be, trees, cars, buildings. Well, cars, maybe not such a good example, but parked cars. And obviously we got tools to also bring dynamic keyframed geometry into your scene. But here, that process, once again, is only for geometry, which will not be animated for the whole duration of the shot. Great. Okay, so now we've got that terrain node. So the entities know about the limits of it. They know about the ground. They know about the obstacles. So now we can start populating our scene and adding our character in the scene. So let's start with the fortress soldiers. So the characters which will be quite disorganized and which will just rush into the Roman soldiers. So you decide where you want to put them. And to populate them, we've got plenty of ways. Maybe we can play with a way we have not been playing with so far. Maybe we can play with, the box, or maybe with the polygon. So let's grab the polygon one. So that's the third icon. It means that I can draw polygons with it. It can be a good idea to switch to wireframe before placing your points, so we don't have collisions with the ground geometry. So you can switch to wireframe. If you're not familiar with this, you can just press the 4 key on your keyboard. So the number 4, if you've got a keypad, or I think that's going to be this icon here into the viewport, right? Yeah, that's this icon into your panel here. You can just switch to wireframe. So double click on the pop tool, make sure that you've got that open geometry selected. And now we can, place our different positions. So the first position you place, you will not see it, but as soon as you place a second one, you'll have a line growing. And if you place a third one, you'll get a zone growing. So yeah, you can, click until you have a shape which is doing what you want. And when you're happy with that shape and you want to finish it, you can press enter. And as soon as you press enter, now that shape, closes, and you can see your various population appearing on it. By default, we only have 5 slots on it. So that will be, our goal to change this to add maybe more character. Also, one question I often get is, can I change my shape afterwards? So the answer is yes. You may notice that in your viewport, you've got those weird locators everywhere you've been clicking. So those weird locators can be accessed from your population tool. You can see that now it has a plus control that you can expand, and you can see all the manipulators. So you can grab any manipulator, change it to change the actual shape. So let's maybe reduce it. Okay, great. So obviously, now that we have our terrain in our scene, if we move the population tool, you can see that the positions, they are adapting to our environment. And also, if we go outside of the environment, you can see that we always make sure that we are not going to creating characters in zones which are not available from our characters. So outside of it, you can see that it's controlled and you don't make mistakes. Great. So let's place that shape here. Let's control how many characters we'd like to have into that shape. So I have 357, which is good. Let's say that's going to be my battlefield is going to be here in the middle. That's going to be good. So next is changing the orientation of my characters. So here they're not facing the right direction. So let's change this. And also you notice that I'm populating in that scene green guys and blue guys. So quick reminder, green guys are Romans. Romans are going to be really informations squared. Fortress type is going to be those guys there. So I want to control my repetition of characters. So I want to go into my population tool. I want to expand the entity types attribute, which is closed by default. And I want to put my Roman type to 0 to make sure that I'm only populating my soldier fortress. I can change, well, you can do whatever you want to, right? You can change the distance between the characters, noise them a bit until you figure something you really like. And when you're happy with that, don't forget to press the create button. And as soon as we press the create button and we rewind to frame 1 and evaluate a frame, now we'll get our characters being displayed. Great. So far, so good. So you can see we've got geometry variation. Some characters has different weird helmets. different weird shields, different assets into their right end. So okay, so far so good. So I can probably hide maybe that population tool so it doesn't mess up with my viewport. Okay, so I've got my 300 characters being created in the scene. And what I will probably want them to do is rush into the other side. So we'll probably create the Roman soldier afterwards. Sorry, I haven't seen that. I had the questions remaining. So one question which was asked is, can we add a point after it's been closed? The answer is no. Once it's been closed, the pop tool is kind of created and exists. So you can't go back into the manipulation mode. So make sure that you create as many controllers that you want, but you can reshape those controllers exactly like you want. So if you want to have to be able to have control on the shape, even once it's been closed, it's probably to rely on geometry. So you can even have a pop tool which is connected to a Maya surface, like a Maya mesh. And once you create this on top of a mesh, and you reshape that mesh, like change the vertices of that mesh, the population tool will adapt. So if you know that you require flexibility, probably it's a better idea to rely on an actual geometry, so it will be live connected and you can change that shape afterwards. Okay, so yeah, let's make those guys go on the other side, and we're fine-tune the targeting a bit later, but that will be also the opportunity to play with some behaviors we have been playing with so far. So far we've been only playing with motion behavior, which allowed us to just play a motion clip, but we had no avoidance, no motion adaptation to what's going on. So let's open my behavior editor. And let's edit the behaviors for my blue characters. And by the way, something I should have also specified is most of the time when I tend to work making some shots, my soldiers, they always look all the same. So let's say you'd like to see really the difference between who's the fortress soldiers and who's the Roman soldiers. You can also change the way they are displayed. Right now they're displayed with all their textures, which is nice, which helps having a good idea of what's going on at render time. But let's say you want to rather see who's who. You can go into your entity type. You can go next to your display attribute. So you've got the drop down of what's the mode you want to display your characters in. You've got the color that you can change. And you also get a slider value called display color weights. And if you push that color weight more and more, it will turn the characters less into the texture and more into their colors. Or if you turn it down, it just to show the full texture. So it's a good way, to really figure who's who when you got a battle and all the characters messed up. You're not really sure if it's a Roman character or soldier or fortress soldier. So you can just color weight those guys. So okay, now I know that the guy I want to control, there are the blue ones. So it means that in my behavior editor, the characters I want to edit the behaviors for, they are going to be the blue ones. So I'm going to expand my fortress type shapes. I double click on them. So that opens their behavior container. And this time, rather than just playing a motion right away, I want them to reach a target. So, well, let's do some homework. I've been speaking way too much. I want them to reach a target. Which behavior would like to use? So you can check, depending on the icons, is there something which makes sense more than something else? And if yes, which one? So the first answer goes, and they tell me to use the first icon, and it's called go to. The first icon go to as well, which makes sense indeed. And you may have noticed that actually we've got also at the bottom of the behaviors, we also have like some targets also on birds and some targets on cars. But that's true that the first one is probably the one I want to use there. And if I order the mouse on it, it's called go to behavior, which compute a path to a target. That's pretty convenient. So let's drag and drop that one. And let's put it into my flow of my Fortress characters so it becomes active. So that's my go-to behavior. As always, it has my attributes. So I can select that behavior and see what's available for me to tune. So also, if you're not using 813, the way those attributes are organized might be slightly different. We try to make them more easily organized. So hopefully they are the same name of parameters, but they may be in different positions in your interface if you're not using that exact same version. So let's see what we got. We've got a drop down, which is the reach mode, and the value can be reach or flee. So the go-to allows you to either go to a specific position or go to the opposite of a specific position. Let's say there's a danger in your scene and you want all the characters to, flee that actual position. You can just reverse that go-to behavior if you want. So I'm gonna actually reach a target. So what's gonna be my target? And if I also check the drop down here, I've got plenty of options. So first, I've got a random target into the environment. So as the name tells, we're going to provide a 3D position randomly for every single character in the scene. And that random target will be computed thanks to the navigation mesh. So we make sure that we don't ask a character to go into an obstacles or outside of the environment. Then we can use a target locator pop tool, but that means locator. We can use a particle system. So it means that we can ask every single character to target a particle system, a Maya particle system. We could use an attribute, like just write for every single character a 3D position. We can also use an expression of a go for expression probably today, actually. We're going to probably change this to use the expression. So I'll let you the surprise. We can follow a curve, or we can even target a geometry. So we can target a mesh. That mesh can be keyframed, and we can target vertices or faces or edges of that character, of that geometry. Let's stick with the random targets. We're going to change that, obviously, but let's stick with the default parameters. You may notice that you've got also a checkbox called target is dynamic. If you're using a previous version, that target is dynamic is probably going to be around here. So it's going to be below in the interface. So by default, please consider that the target you're going to provide is going to be evaluated once. When the simulation starts, we're going to read the data, apply that to the character, and never change it for the whole duration of the simulation. Let's say that that target is animated and you need to, maybe it's keyframed or maybe it's another entity in the scene, and that entity is moving. You want to say my target is dynamic. You want to specify it to Golem. So we force ourselves to update the positions every 10, and every 10 mean every 10 frames. But here, for now, my target is not going to be dynamic. So let's stick with the default parameters. Okay, so that's first behavior we want to drop. And, if we just run the sim, oops, we don't get nothing. Your character is not moving because that behavior here just compute a pass to a target, but nothing else. If I actually select a character, I can see he's playing the go-to behavior. And if I go into the Maya viewport settings, no need to go there, but I've got some controls to allow me to display where's the target for the character. And we can see, okay, that character pick a target, which is at the opposite, obviously at the opposite of the battlefield. And, the go-to behavior, that's just the job. It just compute that pass. That's the only job of that behavior, which is picking a target and computing the pass to go to that target. So that pass here, so you've got two representation. You've got the pass to target, which was that weird shaped pass. So this is not what we're going to use. That's just a way to override, represent the way it's going to move into the environment. But more the local target pass is probably something that we're going to use for following. So it doesn't mean that my character will do a straight line. It just means that that's the overall direction we want to use for the character's movement there. Great. So we need to actually add a second behavior in addition to the go-to, which will allow us to follow that path and avoid the other characters and avoid the obstacles into the environment. So let's check into the behavior editor. What else do we have? what other behavior could we use to follow that path and avoid what's going on in the scene. It looks like some people anticipated my questions because the answer went pretty fast. So I've got as an answer second. So yeah, let's check what we have as a second behavior in the list. We've got a navigation behavior, which allows to define a 2D.5 avoidance strategy based on a navigation mesh. Great, so let's bring that behavior. And where do we want to plug that guy? So we've got three different possibilities. Should we put it before? So we do avoidance before computing a pass. Should we put it after? So it means that first we compute a pass and then we avoid, or should we put it at the same position? So people at the same time will go, so compute a pass, update a pass, and avoid. So what do you say? In parallel with the first, I don't know, I would put it after. So yeah, you want to put that. So here, keep in mind that that go-to behavior will update itself frequently. So you will take a look at what's the current character position and compute a pass to reach the target. So we actually want those two behavior to play at the same time. So the go-to updates itself to reach that target, which has been specified. And we also want to avoid the other characters. So we're going to drag and drop those two nodes at the same position. And once again, do not forget, like, if you want to see what's going on in your scene, to rewind the simulation to frame 1 and press play. And let's see what we get now. Now we get our character picking a random target into the environment. Each of them is picking a random target. They are not animated. They are just avoiding each other. But obviously, as there are T-pose with a lot of props, and we define the bounding box of the character to be pretty small, they are just avoiding at the bounding box level. So this is why they are kind of colliding with the shields. As soon as they reach the target, they just, stopped by themselves. I can see that I've got my guy disappeared. So yeah, if you got, if for some reason the simulation is not doing what's expected, do not forget to use the check scene settings. Maybe if you're deleted, let's go into, let's say for some reasons, maybe you press delete on your particle system. Obviously, the next time I'm gonna first sim, I don't get anything. So if for some reasons I deleted that node, if I expand now the check scene settings, it should tell you that, okay, you need to have one particle system in your scene connected to a crowd field. So it means that I need to recreate my system. And now my character should be there. And also something that you may want to check if that your Maya play every frame is set up properly, because if for some reason the first frame is skipped, the simulation will not be initialized and your characters will not appear. So hopefully you can fix that. Great. Yeah, and do not hide the particles. Sorry, yeah, I should have specified that if you hide any of the nodes, rather than hiding the population tool, you're hiding any of the simulation nodes, the simulation nodes will not be executed anymore. So, okay, great. My characters, they're, reaching the target, avoiding each other, adapting to the terrain, avoiding the obstacles in the scene, but obviously they're not really, converging to the same point. So what we probably would like to do is having them, going into the other side of the battlefield in the meantime, and maybe we fine tune that later to figure what's the closest enemy I can find in my battlefield. So how do we do that? Let's say we want to target another specific place in the scene. So let's see what we have into the go-to behavior. Let's go into the attributes. So we probably need to change the random target environment and use maybe another mode. So one more we can use is the target pop tool. Let's set that mode into my go-to behavior, go from random to target pop tool. And as soon as I select target pop tool, I've got my drop downs right below are turning into active. And I can select a target locator. So you can actually create a target locator from the shelf. You've got this icon next to the behavior editor in the visual feedback. You've got the same icon than the behavior we've been using. And if you click on that node here at your scene origin, it's going to create, it's going to create a locator, and you can move that locator around, and that locator will define the actual position, the actual target position for my characters. So you can see when you move it, it adapts to the ground as well. And actually, you may have noticed from the attribute editor that this node here is a pop tool. So that's the same node that we've been using to create our characters, which means it has position controls, grid controls, columns and layout, columns and rows controls. So you can also change distance. Ah, damn. Sorry, I was afraid by this. So let's 8 p.m. Yes. Yeah, there's no way I can deactivate this. So yeah, every time I'm gonna shoot the session at the office at 8 p.m. I'll have that surprise. Well, it's too bad because now it's almost summer, and outside it's still sunny, but yeah, I'll have to do this with the light. Anyway, yeah, so that population tool, I can control the positions in it. I can noise that, distance that. So that's it's an actual population tool, but that's just when you create it, it just created with no slots in it, just a 1-1 grid, but you can just decide whatever you want to. So and if you provide positions there, they're going to be used by the characters to go to various positions. So let's say you got 400 position and 300 characters, it's just going to scatter around those zones. If you got less slots than characters, you'll have multiple characters gathering at the same point. So now that we've been creating that node, if we want the characters to target it, we'll just have to go into the go-to behavior and say that the pop tool, target pop tool we want to use. So in the dropdown, you can see all the pop tools which are available in the scene. So obviously you've got the pop tool which has been used to create the blue characters, and it's named pop tool shape 1 or pop tool shape whatever, depending on how many you created. And when you created a target, we change the name, we prefix that node with a target name. So that target I've been created is called target shape 1. So this is what I want to target. And the next time after the SEM, now I got all the characters converging to that target. So they don't go into the random positions anymore. They're all converging to my actual position I've been creating. Great. Well, they're not moving that fast, but we're going to arrange that a bit later. Awesome. So it's now I know that it's 8. I got an obvious signal about it. So should we make a pause now or should we do it later? Let's pause it now. That will be a good thing to pause it now. So after we can talk about how do we animate those guys, and we provide a nice animation to those guys. Yeah, that's going to be a big chapter. So probably let's take a break before it so we can have this tackle this being fresh. Well, before doing the break, any questions with what we've been doing so far? So as a reminder, we compute the geometry to be able to extract obstacles. So those obstacles can be taken into account for both the population, so spawning the characters, but also navigating into the environment. We spawn the characters using a free drone tool. And on those characters, we assign 2 behaviors: going somewhere. So going somewhere, make them go, reaching a specific position, and avoiding each other. So if for some reason your characters are not moving, keep in mind that anytime we provide a lot of feedback about it. Let's say maybe you didn't provide the target in the go-to behavior. You say no target poptool because you didn't think about it. The next time you're going to throw a sim, you'll have error messages or warning messages or plenty of different things. So here, for example, it tells me that my shame container is incorrect. Child behavior has read the warning. So once again, I want to go into the script editor and I want to go back into my previous messages. And now it tells me that my go-to behavior is in mode use target pop tool, but no target pop tool is mapped to it. So rather use the target, random target instead if you don't want to provide the target. Or if something else is not moving properly, pay attention to script editor for errors. Or if you don't know what's going on, you can also select a character and see what's on. So especially if I go into the visual feedback, you can see it's orange here all around. And if I select my behavior here, you can see that it tells you that your pop tool is not mapped. So yeah, we try to be really verbose in the software to help you figure what you may have missed. So yeah, pay attention to the different various messages. And if that does help, let me know. So let's, yeah, it's 8:05. Let's make a 15 minutes break here. And let's meet again at 8:20 then. Yeah, sorry, I said 15 minutes, but yeah, 15, 20. Wow, no big deal.